Okay. So if there is no question, then we start method. Then when we say method, what do we mean by it? Can any one of you give us an idea of what we mean by method? So I've said this several times, but let me see if you can remember. When you relate it with the behavior of human being, what can you say about method? What is method, literally?
The actions performed.
Okay, yes. Action performed by object, an object that belongs to a class. So that is what you mean by method. So please just have it at the back of your mind that any activity or any action or any operation that's something or someone, which that something or someone we are talking about is an object that needs to do, is what you call method. And if you look at it from the student perspective, can you give me like 3 or 4, 5 things that a student is expected to do so that we can look at it as a method? Can you give me 1 or 2 or 3, 4, 5? Right?
Write exam.
Writing.
Read their
Okay.
books. Read their books. Read their books.
Yes.
Attend lectures.
Attend lectures. Thank you.
Also study. Make research.
Okay. Okay. There is also asking question in the class, answering question in the class, just as yeah, answering question is a method. Yeah, so there are a lot of things like students leave, student eat, student ask questions, student do assignments, students borrow pen, students anything you can think of as long as is associated to that object that belongs to a specific class in discourse, then is called method. But method is different from attribute or properties, because when we are talking about attributes, we are talking about something that can be used to identify object. Like we said, your name, your email, your phone number, your contact address, your gender, those are your attributes. And those are the ones we use either of the primitive or reference or type of a class to define the type of the objects or attributes of that class. Okay, so today's class, we're going to see what is the meaning of method. And we have seen method even from the public static void main is a method, but that method is the first entry of every Java program. It's a method, and we're going to talk about each of those things, even though not everything, of course, we're going to talk about, because there is a static keyword in the main method, which is too early to introduce the static void main. Unless if you can remember the Cox 212 we did, then you can relate it to that. And of course, if you understand what is static, then you can understand everything in public static void main. But right now, even if we are to talk about the public static void main, it's just to tell what is it for and how or what is the meaning of public. Even the public should be much later when we go to access modifiers. The static keyword, of course, we talk about the static keyword, and the void, because the method doesn't return any value. The name of the method is called main, and that must be spelled the way it is spelled. That is it. If you write anything different, then as far as compiler is concerned, you are writing something different. And when you come to run your program, you're going to encounter issue, error, that is runtime error, exception in thread main. It means main method is not found. So you need to define that. So if you write anything different, I think the only thing that could be changed in the public static void main is just that X. If you like, you can just write A, not X. If you like, you can write argument, a complete form of it. So that's just the thing that would going to be different. But the string must be, the public must be, static must be, void must be, the way it is spelled, main must be the way it is. Any other thing will not be accepted. Okay. So we're going to see the structure within a class. Instantiate an object. How do we create an object of a class? When we talk about instantiation, we are talking about how do you create an object. Okay, we say a car. A car is a car. Generally, we know there are many cars, different model, and the rest like. Oh, so when we are talking about a specific car and say, okay, I mean this car that you are driving. So we need to have something that can represent the car you are driving so that everything we're talking about, if we are going to make the car to move, we know which car is going to move. It's not just to say drive, then it means it can be any car to drive. No, we have to know which car to drive. So for you now to construct that, to say this is a car that will be given instruction to move, to stop, to do whatever, then that is what you mean by instantiation. So to instantiate that object. Now, understand the benefit of methods. What is the benefit of methods? So we're going to understand this also for modularity and make things easy, to make it tied to a particular object, to do a specific task and things like that. Then we see how to call the method using a dot notation or dot operator. We use a dot to access object fields and methods. So the fields, you remember, field means attributes of object, and method, we use a dot to access. Very soon, you're going to see, which, if you can remember, to some extent, we have done that. I remember, even yesterday, I think we used Jobson Pen, right? If you remember, Jobson Pen dot show message dialog. That Jobson Pen is the name of the class. Dot is the notation that used to call the method. The show message dialog is a method there. It's a method. But then later we see why do we say Jobson Pen is a class and that is a method? And show message dialog is what you call static methods. But I don't want to introduce it now until we go down to see different types of methods. Then we can talk about the static. So how do we supply arguments to a method? An argument here is just to say, okay, I give you instruction to write. The next to ask me is, what am I going to write? So if I give you what to write, is what I need to pass as an argument to give you something that I want you to write. You want to withdraw money. How do you go and withdraw money without amount that you want to withdraw? How do you go and deposit money without going with an amount? So in such kind of situation, that means whenever you are to define a method called withdraw or deposit, you need to have an argument. That argument is what is required for that transaction to be completed. Of course, in real sense, we can't go and say we want to deposit without going with money to deposit. So that money that we are carrying is the argument that we can take along in order to go and do whatever operation or whatever transaction is necessary. Like I say, you can write. We normally see system.out.print line or print something. Then we put something in code or in bracket, or we print A, B, C, any variable like. So the print is a method, but you are passing an argument that you want to print. So that is called an argument. Then we see the return values of a method. If a method is going to return value, how is it going to return the value? What type of value does it return? Does it have the return in real sense, or it doesn't have a return? So by the nature of the method will be informed whether there is need to have a return or need not to have a return, like that of the main method, because it doesn't need to return any value, and that is why it is declared as void. So we're going to see each of these, and this is the objective of this chapter. Then, so we said in Java development, you will encounter many classes for many different object types, including classes you will write yourself, classes written by someone else, and classes belong to Java. Yes, you should have it at the back of your mind that, remember, even yesterday we imported some classes like Jobson Pen is a class that is belong to Java. And it's possible that someone may write an API you want to incorporate into your program because that problem is solved and you want to now bring it into, just like we know normally import library into our work. Like, so it could be possible in Python, in Java, and the rest. Like, we use this API into our program and the rest. Like, so it's possible that class is written by someone else and you want to bring it into your code, like to make use of it. Especially when there is such kind of simulators. I remember one cloud sim or grid sim for cloud computing, where some of these classes of how communication and the rest like resources will be shared are already implemented. All you need just call all the various classes, call the methods and everything because there is a proper documentation. So if you know how to write code, then you can manipulate it to achieve something. But the basic foundation is provided for you. Okay, it could be like, okay, the classes that you define yourself. This is why they say, okay, the classes that you have created, or it could be a classes that could be the classes that are created by other people or classes that are belong to Java. So those classes, even if you can recall, even yesterday we did a scanner, and scanner is a class. So that is coming from Java, belong to a Java. And you can write your own class and give it to me as an API, then I can use it. So that is a class written by me, but you want to use it into your code. And you may create your own also. So in addition, you may have 3 different categories of classes. So these classes outline objects, that is properties and behaviors, which is fields and methods. Properties or methods. So now the goal is for you now to be able to understand on how to work with any class, field, and its own methods. As long as you can create a class, within the class, look at the possibility of all the attributes of the class. Like say, for instance, we are looking at a book as a class. Now we have various books. So each book has its own title, has its own ISBN number, has price, has whatever. Those are the fields. Those are the fields or properties, if you like. Then there are some certain methods of each of the book there. Now, so those methods will be defined, fields will be defined, and class will be defined. Now, the remaining lesson of this is to explore important classes provided by Java. That is the classes provided by the Java API, standard API libraries, which we have seen some part of these classes, and we have enjoyed the use of them. Even yesterday, one of the students, I think, also asked for the clarification between, or the difference between buffer reader and the scanner. And even the buffer reader is in the java.io package. So the buffer reader is a class, input stream reader is a class, scanner is a class, Jobtion pane is a class. We all imported them and used them. Well, they are all coming from Java library. So now next is how do we explore classes and methods in more deeper way. So you take exercise 1, which if you refer to that, you'll be able to see the exercise. Let's talk a scenario and see how we can model the component involved. It's Alex's birthday. You have arranged a group of 8 friends to celebrate at a local restaurant. When your party receives their bill, nobody is quite sure what they owe. You only know everyone's total before tax, 5% until 15%. But lucky you brought your laptop and are asked to write a program to calculate every day's total. So now looking at this, the first do, how do you understand or how do you extract to know which one is supposed to be a class? What should be the attribute? What should be the method of this. So this is a word problem given to you. All you need, just try to read, understand. How do you identify the classes itself? So who can give us an idea? Let's look at this together. It is Alex's birthday. That is the topic, the subject now. You have arranged a group of 8 friends to celebrate at a local restaurant. At a local restaurant. So remember, we said we have what? How many friends? 8. When your party receives their bill, okay, so now receives bill. Nobody is quite sure what they owe. You only know everybody's total before tax, 5% until 15%. But lucky you brought your laptop and asked to write a program that calculates everybody's total. So how do you go about it? What should be the name of the class? How do you get the total now? Will the total now, after you get a total, will you throw away the total, or you're going to return the total? Yes. Question? That means you need to have a method. You need to have a method that will get the total. So when you get the total, will you now throw it, or you're going to return and say this is the total?
I think we should just print the total.
Okay, so and when you are to get a total, you get a total for how many number of friends?
8.
8 friends.
Thank you. So you see that we have 8 friends. And so if I told you I had to choose something like maybe a name, a class, what can you choose as the name of your class? Something meaningful that is related to the context.
Since they are friends, I think we can use persons.
We can use what?
Person or friend
Person?
1.
No, I don't want to use a number, friend 1 or something like. Okay, so you say person, that's fine, but something, just look at it again and start and bring something very closer. It could be noun or noun phrase. Even if it is long, let it be noun or noun phrase from the name.
Are you talking about the name of the file or the name of the friends?
No, I mean, if you remember when you are to write this using object-oriented, you want to start with a class, right? You say public class something. So what should be the name of the class? Let's choose any something meaningful, very close to the main, so that by merely looking at the name of the class, you know what's likely this class is going to. Sorry?
Can we use birthday?
Yeah, we can use birthday. That's fine. We can use birthday.
Alex birthday.
Yeah, we can say Alex birthday, which is a noun phrase. Thank you. Yeah. Something, any meaningful thing that at least whoever sees that will realize that, oh, this is what we are trying to do. Alex birthday, fine. That's great. Yes. Or if you like, you can call it local restaurants. It's still fine. Or you can call it restaurant expense. That is fine. Yeah. So that's it. So now the number of friends, and you need to know what each of them have spent. Then you now calculate the total. So all this we know we can easily get something. Okay, so please again check this material. So the exercises and try at an allotted time. So now next, modeling object. Yes, still in line with that. You may have been tempted to model each person's total by writing this. Let's say we say tip 1, just to say tip, you know, from the word tip. It's not because it's the best name, but just say tip 1. We may have another tip You may have another tip. Yeah, just about the same program, the same question we asked here in this particular one. Okay, so now we start with the class and public static void main, this. We say person one, this is person one. Remember, we have how many persons?
8.
8. Okay. So you remember that sometimes we start with something and we see the kind of complexity. And then we now say, oh, so because of this complexity, we now make it this way to make it easier. So if I'm going to say person one, total 1, person 2, total 2, it means I have to calculate if I have 1,000. Does that mean I have to say person 1, total 1, person 2, total 2, person 3, total up to 1,000 lines? That is crazy. That is crazy. That shows that it's not a program. It's just a method. So we provide that, and this is what will motivate you to know the importance of having a method there. Okay, so we say person one with this amount spent, and then we said this person one, which is 10 times whatever the tax and the rest, like the tax entitled for that and everything. So this is, suppose this is the formula to get the total, and this is printed for person one, which you are to repeat for person 2, person 3, person 4, up to 8%. So this is it. But don't mind about this. This is just to tell you that 15%, 5%, isn't it? That is just the thing. 15%, 5%. That's all. Nothing more. It's just the issue of tax there that we have mentioned. 15%, 5%. Then plus 1 times 100, whatever it is, the way to calculate, which is basically if somebody come to your shop, buy something, and this one buy something, or this quantity, you know how to calculate to say this is your total. So that same formula you just apply, depends on the scenario. So this is our concern is not on whether this is the right calculation, because it could be like somewhere maybe it's just 7.5% tax that you need to pay. So it's not the same. What under the condition that we have two taxes to pay, 5% and 50%. Okay, so this is one. And then moving on to do for the same person 2, which is the same thing, only that this is person 2, this is person 1. So you see, when you needed to model 2 dinner guests, you may have been tempted to copy, paste, and rename. That's it. You copy this, paste, and then rename. And rename this, instead of 1, you make it 2, 2, 2, 2 to make it for person 2. The same you repeat for the next one until you have all the 30, all the number. So now we say modeling many objects. What if you need to figure 1,000 guests? Like I said, 1,000 guests. Does that mean you have to say person 1? You have to repeat this up to 30, up to 1,000 times? Imagine you have to say person 1, total 1, this line 3, then you repeat the same thing for person 2, you repeat the same thing for person 3 up to 1,000. Huh, crazy. You know, even from there, you know that for you to write these 3 lines up to 1,000 times, that means you're going to have 3,000 lines apart from the space line break. So which is quite tedious. And each time there is any mistake, you have to go to every person to modify, which is not a good practice. So you see, she's even scratching her head because it's very tedious to accomplish that. So what if your friends forget their wallet? What if you made a mistake with your formula? So you have to go through to every person there from the first person up to 1,000 person and modify. So you might think, do I need to make 1,000 edits? That is the trouble now. You see, so already she's scratching her head because the formula is not correct, and someone asks you to please modify these changes. I think even in Microsoft, in Excel, when you have, if it is a formula, the best is apply, put the formula in one place and then copy the formula across. That makes it better. But imagine if there is no such kind of possibility of you to apply the formula in other cells, like, so you have to repeat the same thing. If you have 1,000 lines or 2,000, 3,000 lines, you have to do it for everyone. So that is one good thing about programming. You always make sure that you provide the best possible for users. So there has to be a better way. Definitely, there has to be a better way. This is not the feasible way. If I have 1,000, this is 1,000. Sometimes we may have like 2,000 guests. So writing a program that has to do with a dynamic number of guests, it's not easy to do that with these 3 lines of computation. But when you make it the best, which is the methods concept, then that will make it better. Okay, so variables offer flexibility. Yes, we offer flexibility. We are now moving step by step on how to make it much more easier. Suppose it's just a 15%. You apply 15% here, the 5%, 15% across all the users, all the persons, all the guests here. So if this 15%, 5%, 15% and 5% is not correct, maybe need to be increased or reduced. So you have to do that for every person, for every guest. That percentage or the tax need to be modified. We said still not good. We use a variable to say tax and tip here. So for the tax, 15%. Then, so the 5%, we write it here. So instead of now hard coding the number, you use the tax and the tip here in place. You see, tax and this. So when you are done, the next to do, if there is any mistake, all you need just come here, modify. That's all. You don't need to go and do it elsewhere. Once you modify here, that's fine. So this simplifies the process. If in case the variable is the trouble, but if the formula is not, then you have to do it for everybody again. So, but now we are on the variable first. We start with a variable because it's variables offer flexibility. So if it offers flexibility, that will eliminate the need of going through every record to modify. Okay. So I hope this is clear, right? Guys, are we following?
Yes, sir.
Yes, sir.
Okay.
Yes,
Okay,
sir.
great.
I have
Now-
a question.
Yes, please go ahead. Ask your question.
The previous page.
Yes.
Yes, could you please just scroll back upwards?
Yeah.
No.
Yeah.
Okay, here.
Okay.
Now, the entry point where you said public static void main, the whole thing should
Yes.
remain the same. But I observed the array representation is not coming up immediately after the string, but in front of args. Does it still do the same thing?
Yes, it's a very good question. This is an array. An array can be declared in 2 ways, even though we go to array, but let me just explain this. Array can be declared in 2 ways. I can declare an array as this. That is 1. I can declare an array with the square bracket here, A. This is 2 ways now already. So the square bracket can be just after the type or after the variable. Either way is fine. Okay?
Okay, sir.
Yes.
Thank you,
So
sir.
you can declare an array like this, or you can declare an array like this. Either way is fine. Yes. Thank you. But the only thing that's if that will make it not work is only when you misspell this. Let's say this public is not there, or static is not here, or void is missing, or main here is written with capital M, or I is missing, or something case is not the same. The string is not written the same where But this acts of a thing can just be an A. If you like, I can use AR, I can use AG, I can use S, I can use, as long as it's a valid identifier, meaning that it must not start with a number. It must start with the letter of alphabet, and you can have an underscore and the rest like. And these square brackets can come here and can come here either way. So because it's an array. When we go to array, we will show you these two ways, which either of the two you take is fine.
So still on that
Yes.
same page. Still on that same page.
Okay.
The
Yes.
10,
Okay.
10, this double person one equals 10. I thought the 10 is an
Yes.
integer. So why
Yes.
is double there?
Yes, it's an integer, but you remember we talk about the narrowing conversion. So yeah, narrowing conversion. That is coercion, where we said from the lower, you can assign from lower to a higher.
Yeah, it's true.
When you assign from a lower to a higher, then the Java compiler will accept it. Only that it does the conversion for you automatically. It does this to a higher. This one that you are assigning a lower to a higher, then it will convert that lower to a higher. But from higher to a lower, the compiler will not do that for you. You have to do it explicitly. But this is implicit. So when we have 10, when we assign 10 here, let's say you go down and say system.out.println person 1, then definitely person 1 will not just be 10, but rather 10.0. That means compiler has implicitly converted that 10 to 10.0.
Yes, sir.
Okay? So,
yes, sir.
yeah, let me just show you here. It's an interesting question. So when we say system.out.print, then let me say person 1 like this. So I run. Instead, you will see 10.0 rather than 10.
Yes,
because we are assigning a lower to a higher. But one thing that cannot take is take this one as integer, and then which is if 10 is 10, then 10 is integer, assign integer, which is fine. When you run, you see 10 rather than 10.0. That one, you know, it's no doubt about it, right? So now, but one thing that cannot be possible is when you make it like this. This is not allowed. It's not accepted because from higher type to a lower type, how can you store that 64-bit to 32-bit? It's not possible. Yes. 32-bit, 64-bit to 64-bit is not possible. That is 8-byte to 4-byte. It's not possible. So this will not be done by the compiler. If at all, the implicit is not possible. If you want, you can just simply cast it like this, then add an integer here so that this 10 will be 10, 10.0 will be 10. By casting with this int, then you run, you get your 10. No issue. So this is the explicit conversion. Otherwise, that is not possible. Okay, so this is fine now, or this is fine. Okay, that's clear?
Yes, sir. It's clear. Thank you, sir.
Okay. Okay, so now we talk about the variables offer flexibility, and then method offers similar flexibility. Method offers similar flexibility. Now, instead of repeated patterns, something that is repeated over and over, like let's say repeated behavior, I know you will eat. I know Ismail will eat. I know Godu will eat. So why do I need to repeat the process of eating if I know every student is going to eat? I can just define one method. All I may probably ask you, tell me, what do you want to eat? Then that is the parameter. Yes. So all I'm just to define a method, eat. The behavior does not mean I have to have your own copy of eating. I have to have a copy of eat for Godwin, Ismail, and Fatima and say, oh, this is the way. No, we can just aggregate and just come up with one single method. And then all we need just to specify is what do you want to eat? We pass it as a parameter, and that's all. So the same maths and printing behaviors are repeated. Instead, this logic can be written once in a method, So if you have the methods that will just have this, and then all we need is probably just to have the parameter tags and pit, and then that's all as a parameter, and the person, that's all. So here we go. This is the same thing. This is the same thing. It's just repeating. So why can't we have a method? Okay, so when to use methods? It is a good idea to write a method if you find yourself repeating every similar lines of code, including calculations. Guys, by the time you start writing program, you will see that method is fantastic. Method in some languages, they call it function. It's fantastic. It's actually fantastic. It makes life easy. In fact, you write, it avoids unnecessary repetition of writing code. You make it modularity, make it flexible, make it better, make your code neat. Okay, so need to describe object behavior. That is what we mean by methods. Object behavior. Yes, object behavior. So the repeated behavior for an object can be modeled as a method, which need not to be repeating itself. Okay, so now, how to use a main method. Thank you, we're here now. After we said that, so instead of introducing something else, we talk about the main method that we have been talking about right from the onset. From the day we first write Hello World program, we wrote public static void main, but we said it's too early to discuss the main method that time. So, but today is our great day. We can talk about the static void, the main method. So the main method is known as a driver method. Is a driver method, meaning is the one that drives every other method, and that is the first entry of every Java program. It's just like you coming into the house. You come through the door or the main gate. So you come through the main gate. From there you reach other places. Like, so the first thing that Java compiler will start looking for is the main method. If that main method does not exist, then error will be thrown. Exception in treatment. It means there is an absence of main method. And let me show you here, like, you see this program, I run it fine, but if I change this now, that this main method is no longer the one. The compiler will assume this is something that I mean to define myself, not the one that is understood by the compiler, because it is not properly spelled. I begin this with capital letter, then it's no longer that main method that we know. So if I run this, I will compile, it's fine, it will compile, but running is to not. But remember, when we do this, we are building and compilation at the same time. Compile and run. Okay, so now I click, I do. So can you see that? Main method not found in class, student this. Please define the main method as, you see, as what? Look at it. As this. So it is not seen it the way it is. So if I now go back, change this to a normal, and then try to remove the static, then that is still not the one. Because it's not every method that must be static. But because there is no main, then it says main method is not static in class student. Please define the main method as, again, because it's so intelligent, it's telling you what is missing and how to define it. So it's still not seeing it because there is no static keyword. Okay, let's bring back the static keyword. Now, next, I will just change this to I will change this to A like this. Will it going to work? This is just a variable, must not be X. Yes, so this should work for us. It must not be X. We have our result. This is just a name, but why are we choosing this? It's just to say arguments. That's just the thing, argument. That's why each time you want to name your variable, avoid too much short variable like A. It cannot make sense. But when you write X, then clearly people will look at it and say, oh, this is argument. Or if I like, I can write it completely and say, I mean argument, and that's still fine. My program will run. It's an argument, it's an argument. Or if I want to make reference to this, I make reference to it. That's all. Okay, so the main method is known as a driver. Use it to drive the events of a program. So if there is no, imagine you want to go and there is no driver, where are you going? No way. So the main method is the driver that will drive you into the program. Yes. So if the driver is not there, then the next to say is there is no driver. And there is no driver is there is no main methods in your program, and therefore nowhere to go. Because whenever you are to come is the main method that will drive you through the program. So please take note that main method in every Java application, there must be at least one main method. If there is no main method, then there's no way you can go into the program. Now use it to access fields and methods or other classes. Yes. So we can use this main method to access fields, that is properties that we have defined for a particular object, or methods or other related classes. Remember, when we talk about inheritance, our classes that are from other packages and things like can all be accessed within the main method. Just like we demonstrated yesterday, we use a Jobson pane, and Jobson pane is a class in Java's Swing package. And we have used a scanner, we have used a buffer reader. Those are classes. And possibly that we may have other classes, then import them, instantiate them into the main method and use them. So the main method doesn't describe the behavior of any particular object because it's the main. So it doesn't define the behavior of any object. Yes, that is why we call it, it's a special type of method. It's not like on the method we define to say, oh, it's a behavior of a particular object. No, it's a method, but the method is the one that is serving as the driver. So take it as, okay, method for driving. And driving is an activity. If you like to relate it, as we said, as an action or things that is to be performed by object. Now, keep it separate from your object classes. Yes. So it means you can't mix this into your object classes together. That's why we say keep it separate from your object classes. In most cases, you see, you write a code, you write a class without main methods. The main method should be in where you have the test class, where you want to drive. That is, you remember, we call it sometimes drive class, or we call it test class. That is where you instantiate the objects there to demonstrate. So from there, that is where the driving will start. Because everything you have, the classes you have will be instantiated in the main method. So once the main method is there, the Java compiler will encounter the main method and then start reaching out other classes and the rest like. Yes. So use only one main method for each application. For each application, use one single main method. Yes. So not to have two, but this is just an advice. It's possible that I may have one class here, but within this class, I want to test something without reaching to the other class, then I can have a main method to run that class independently. But it's just a good advice that you make it just one main method. So if you want, you can reach to other methods like. So what do object classes look like? We will change the code to fit the following formats. Let's see how we can get our codes to look like this. Okay, so the skeleton of this is to start with public class, then we have calculator. So the same thing, you can, that of the restaurant, if you like, you can call it calculator. You can call it Alex birthday and the rest. But depends on who is the owner of who is going to calculate. Is it to know the expenses we have spent in Alex's birthday, or is the owner of the restaurant wants to calculate how much money? If it is the owner, then the owner need not to mention Alex's birthday. They better to choose a calculator, because a calculator is the one they use not only for Alex's birthday, but for any other customers who patronize their services like. So we have properties and we have behaviors. The properties are such are the person's number, the tax, the tax and the tip and the rest like, and okay, and then behavior. Those of the methods, like the method to calculate the actual price. Okay, so now we are moving on to define that. Gradually, we enhance it. Okay, so we start with local variables, which are basically the tax here. We make them public, double. These are the tax, the original price. So instead of defining the price for everyone, we just say original price 10. Then we go into the public starting void main. Here. And then this is what we have seen earlier. We define the tax and the race like, and then come and calculate here. This is what we have seen before. And then when we come here, we make it this way. So the solution to this is to factor out to take this away from the main method, take it as a separate class, separate implementation by making this to be a method that each time you want to calculate, just call the method, pass the necessary parameter, and then print it. Okay, so now the enhancement to that, we now introduce what you call find total. Find total is a method without any something, but just to say calculate total after tax and tip. Print the value. That's all. So we say public void. The void here, it means after calculating this final find total, it doesn't return any value. It just calculates and print the result. The importance of returning is when we're going to go further to do any calculation with the return value. Then from there, it's better to have it as a return, because we want to say, okay, what is the total? Add something to it. So for you to add something to the return total, you need to return it. But if there is no need of returning, you can just print out the total, just to see on the screen that, oh, this is your total, that's all. But if you want to maybe add or subtract something from the total, then you need to return it from the method. By then, you can add or subtract whatever you want to add or subtract. And also, if that need not to be as an argument to the method. So this is the redundancy that we said we take it out and move it here now, because this is the calculation of the total. So this is what we take and move it to the function. And the function, the name of the method is called find total. Remember, we said a method always has to be, which is conventionally always preferably to be a what? Verb, an action. So when I say find total, it's an action word. It could be verb or verb phrase. So find total of what? Of the customers or guests. So this is what we need to take and put it here. That's all. Then moving on to the next. Remember, we say move the repeated behaviors from the main method. These are the repeated. We move them to this, isn't it? To this find method, find total. Now on the next slide, we now remove the main method. So After doing that, we remove the main method. So this is going to be removed totally. After we have removed this, we have moved this to this, then we remove the main method. That means the main method is not needed here at all. It's not needed here. But mind you, we have defined all our fields. These are the fields, which are the properties, the tax, TIF, original price. The original price is just to say the default price. So whoever we are to calculate, if the price is different, we can always change it. Okay, so now, success, we are done. We have the fields, we have the fine total, and we have the calculation to the fine total. Yeah, that will move on here. Okay, so where do I put the main method? That is the question. So we now come here and say public class calculator test. So we create a separate class now, you see. We have removed the main method, but where are we going to take it? We said, okay, let's come here and make it another class. We said calculator test, means a test class. So the driving will start from here. It is this that will now call the other class now. Okay, so we have the, you see, after this started void main. But mind you, in this class, we don't have the public static void main because already totally removed. All we have is just this and the implementation of the methods. So here now we have the static main method and we instantiate. This is the what we call instantiation. You see, create calculator object. So it's just like you want to say, oh, okay, I know how to calculate. I know how to calculate, but then I need a calculator. To create the calculator so that you can use it to do the calculation is what we are now trying to do now. So this is the point where here we say calculator, but the calculator is a generic. It's not specific. It's not specific. Defining this calculator, it's not specific, it's a class. But here we come specifically, we said this is the calculator. The name of that calculator is called calc. It's just like you hold a calculator on your hand. And that calculator that you are holding is called calc. So you now start be giving instruction to the calculator to do some calculation. So the way to construct or to create kind of that particular calculator, this is the way to do it. You just say the name of the class. Remember the name of the class previously, we have seen it as what calculator. So always if you want to create an object, you need to tell. It's not like primitive type where we said integer, then we say int here. No, this is object, but object belongs to which class? Belongs to calculator, and the calculator is this. So you are creating an object of this now. Yes, creating an object of this is just like saying having a specific calculator holding on your hand to start pressing and do the calculation. But the class defines what and what needs to be provided before we do the calculation and how the calculation going to be done. That's it. So here we have this. So if you want to make any reference to, then we now call this calc. So we say calc.tif. It means give us the TIF value, and the TIF value is this. Remember, we have the TIF. We have the TIF value, we have the tax. So if you want to call each of these, you can call by the use of what? Remember, we mentioned using dot notation to call attributes and methods. So we use the calc to call the TIF. That gives us the 10%. That is altering a field. Which field are we altering? Remember, we have field here as this one as 0.05 and this one as 0.15. So this can be modified because they are public. When they are public, you can come and modify them here. And now we change TIF from 10% to 10%. So this is it now. That's why we say altering a field. Then next is to call the fine total. Fine total will just change this percentage sign. And then when we say calc.fine total, then it goes to call this. Remember, this is a method. So it's going back to call this now. And this already contains what? this already contains the calculation of the total. So that is basically what it does. So let me just take this and then demonstrate to you guys to understand what we mean by that. Let me just override this. Public class calculator public this public this public this one, then indent. I will indent this. I will indent this. So forgive me, I'm going to use because the name of the class anyway. Let me just do this. So let me come here. Let's say I want to add a class. Then my class, I will call it calculator. So if I will say calculator here, I will not make it to be to have a public static void main. I will just leave it as that. So now I have my class calculator created, then still under the same package, students. So let me say package students. Okay, so double tags here, public double tags. Okay. If you say refactor or format or indent something. Anyway, I wanted to check for auto indentation. So we can indent it like. Okay, so now next, remember that the formula is to do the same as it is done here. The calculation of this is this. So I will now move it here. This is the implementation. So I will uncomment this. I will uncomment this. So it is calculated here. But who is person one? We need to know who is that person. Now, you remember that person one is a value, which if you like, you can just come here and make it to be like int person rather than, so you can just say 10. In fact, it's the same as original price. Yes, thank you. It's the same as original price, so you can just say original price. Yeah. Yes. So if you say original price, then system.out line, it gives us the total. So now let's create the test class. Now, I will delete this guy. I will delete this class, the student class. Yes, continue, guy. Come on. Then I will create a calculator test file. Plus calculator test. So this is supposed to have a public static void main. So I check it because it's my test class. So it should have the static void main. So at this point now, all I need just to instantiate my calculator to create objects, to say this is my calculator. In fact, let me show you. I want to on my camera here just to show you that, oh, suppose this is my calculator. So if I create an object, I mean that's the object that I have is this calculator now. So you can, where is my calculator? Okay, if I hold this and I said I'm writing this, and this is my calculator, so I will now say this is my calculator. So I call it calc. If this is the calculator, I call it calc. If another person bring another calculator, so we call it calc, let's say calc 1, calc 2. So all the same, this is calculator. This, if I want to calculate with this, I call this. If I want to calculate with this, I call this. That's all we mean by this. So we instantiate. Since it is a calculator from the class calculator, so I can instantiate like this and say calculator. Like this. So now we have instantiated. Next, we can say calc. So if you want to now call any of this calculator, if you remember that we can change any of this because they are all public. If they are public, they can be modified outside their own class. So I can come here and say calc dot tip. You see, tip is coming. So I can change it, let's say, to 0. This to 10% like that. So I can change it. I can change, if I want, I can change the original price. Remember that we have original price. So original price was what? 10. So I can make it 12 now. So if I want, remember that there we initialized with something values, but at this point we can modify them. And why we are modifying? Because they are public. That's just the one good thing about bad thing about public something. If it's public, then it can be modified from anywhere. But for now, take it as okay, we are modifying. When we go to access modifier, we talk those in detail. So we said calc dot. What is the name of the method? Find total. So if we execute, this should give us the output because already that is a print in that class. So it gives us 13.8. 13.8. So if we want to calculate for another person, let's say he's on the same tax, but his own price is changing. So we can just say original. Again, later on, we see a better way by using a parameter, better way of handling this. So we can just say here now, his own price changed to 15, and then we call calc. So we run, we'll see the two results. So this is the for the second person. So like that, you see. So if there is any wrong with the formula, why you need to just come and modify is here. That's all. If this is not the formula, this is just where you need to come and modify. And if there is anything wrong with the percentage and all this can be modified here, or you can modify at this point. Okay, this guy we're going to give you, your tax is not just 10%, it's this percent, then you modify here. So if you have the 1,000, it does not mean you have to go and do it for every yes. So that is very tedious. So they will make it this way and make it better. Okay, so moving on, guys, any question on this? Can we move? Can we move?
Yes, sir.
Okay.
Yes, sir.
Okay, so now at least this is what I came to explain, and I believe there is no issue. We have seen where we put on the main method, we put the implementation on the main method. So put the main method in another class, such as a test class, like the one we have done. And the main method drives the action of the program, which is the one that drives how will now compiler take this and refer this control of execution to the calculator.java. Is because of this. If there is no call to this method, call to this constructor of the other class, then there is no way this will refer to that class. And just because of this. Yes, I don't want to talk about constructor, but this is what you call a default constructor. And once there is a default constructor, it is transferred the execution to the class that has that constructor. So I don't want to talk about constructor now, even though we did it in 2 and 2, but my assumption is you have not done it. This is now we are doing. So that's it. So it creates instance of objects, and this is the instance now. This is the instance. This calc is called instance because it's the object now. Now it calls instance field and method by using the dot operator. This is the dot now. We use this instance. The name of the instance is this calc, which represents the calculator. And then going forward to change those values. Just like I want to change your name, I say, let's say p1.name equals to something. So I'm changing your name. If I want to change another person's name, I will say probably if it is p2, I will say p2.change name. Then I change your name like that. Okay. So please use a dot notation, dot operator to call method or to call attributes of objects. Okay, so this is now looking at the variables for objects. We have the integer, which is the age, and we have a string, which is this. We have scanner. You remember scanner is a what? It's a class. We call it SC that represent an object, and we use a new operator to instantiate. So imagine this scanner class is not created by us. And if you can recall, how do we create an instance of scanner? When we come to create a scanner, we say scanner s equals to new scanner system.in. Yeah, so we are instantiating to have an object representing that. And this scanner is not our undefined class, but this is where we have the class that we are creating. This calculator is our class that we are using to create the object. So this calc, the calculator is our defined class. And this calc is the name of the object that we have defined now. That is the name, and this is the type. This is the value. So objects like primitives are represented by variables, but most objects require the new keyword when they are initialized to create new instances. So we use this new operator. Yes, we use this new operator for any object, This is called instantiating an object. Yes. By the time you write this, this is what you call instantiation of object. And there are some exceptions like string objects that don't require the new keyword. So meaning that even string is an object as well. Like this one now, I can say string name equals to new string. Then I will now write the name like this. So this is the same as writing this is the same as this. But for string, we don't need to write the new operator. This is the same. Either I write it like this or I write it like this. Because string is a class. So if it is a class, that means this name is an object. That's why we say string is an object. And that's why we can make use of saying, for instance, name dots to uppercase. For instance, if I want to change to uppercase. So this to uppercase is a method. But method to change what to uppercase, to change my name to uppercase. You see? To change it to uppercase. Something like this. To change it to uppercase. And that's a method. You change this to uppercase. And you see, we use a dot notation. And this name is an object. Then this. But if it is not an object, like primitive, you cannot use dot notation. Like this one now, you come and make use of dots for tags. How? You cannot say tax dot something, because tax is a primitive type. It's not a class. It's not an object that is expected to belong to a class. Therefore, there's no way. As long as it's not an object, then it's not belongs to a class, and there's no many method associated to non-object. So that is that. So except for, this is why I said this is called instantiating an object. Please take note, instantiating an object. We sometimes ask you to write a class, and after you have written the class, the next is to instantiate an object. And like I've said, I repeat, this has a great application. And regardless of the language you take, either way, all remain the same. Take to any language, remain the same. It's not different. Only that's how it is implemented matters. Let me show you this. Let's say this expense item. No, not this. Let me take a journal. Yes, this is a class. You see, class journal extend model. Of course, this is extend, extend from the Java again. And this is attributes and defined to be protected. This is again protected, just the same we have in Java, we have a protected. This is a method. And this method can be called elsewhere. So if I want, all I need just to create an instance of just journal and say, okay, journal, then dots, or may say journal J equals to new journal, then I can use that J object to call any of these methods for execution. Any of these methods, whatever is defined within the class can be called. So if you understand that, then that will be quite simple. Like I said, switching to any programming language of object-oriented is not going to be an issue. Only that some slight differences, you will definitely see it. But not to see something entirely new. So using the dot operator, place the dot after a variable name to access its fields or methods. Like here, we say calc.printtip. So if there is a method called printtip, then we use it to call the method. Yes. And then we change, and then we call the printtip. Okay, so now let's go here. Let's go to this class, and let's create another method. And the method is just to say print tip. So let's say public, let it be void. Let's say print tip. Then I will say system.out.print. Let me use print line. Then I will say tip now. So I say tip. We might not know because here we change the tip now. So before changing, let me see what is the tip. What was the value of tip before I change it? So I can just call here and say calc. I have to use the object because the method that I'm trying to call is in the calculator class. So I have to use the object of calculator class to call any of these methods. Yes. I have to create the object that I have to say, okay, please print me, go and print me the tip value. So this is now the object called calc. Then I will send him. Suppose is the object now. So I'm now going to send him and say, please go and print the tip. Then by the time I'm giving, this is giving instruction already. I'm saying print tip, just like we said system.out.print line. So I'm saying print tip now. So print tip will now going to print out the tip here, and then change this. After changing, we then say print tip. Again, we see the changes now. So now let me go back to this. Can you tell me what is the value of tip at this point? What is the value of tip from this class?
0.15.
Okay, 0.15. So if you come here, we say print tip. What is going to be printed? 0.15, right? Then we change the value of tip here, and then we print it again. So when we print it again, it's no longer going to be 0.15, but 0.10, because it has already been changed. So you see, 0.15, because initially it's having this value, which is printed by this method. Printing is the one printing. Again, I come and change that value of tip to this. I now say, okay, let me print it again to see whether it's going to be this one that I have just changed, which is now here now. You remember 0.10 is same as 0.1. Yes, we know this in mathematics. 0 after decimal points is as useless as it is. Okay, so that way. So you can also create other methods of that. Those are the ones we call them getters, if you like. Okay, so here now we define the method print tip, and then print the tip. You see the value of the tip. Okay, so this is another exercise for you guys. Please, similar to the one we did, create a new project and add the calculator test tool and these files to the project. Complete the find total method, which should calculate a total based on the tax, tip, and original price field. Print a person's total, which is the same as the one we did now. So this is another exercise for you guys. Okay, so here now we say you may have written, okay, what you may have written. You may have written your program like this. That is probably in that exercise. 2 lines are required for each person. Add more if you decide to print names and change tax TIF values. So you depends on what you want. But all that, we have done this. So we change the original price, this 10, the original price, this, and then calculate the find total of the guy who has spent this and the guy who has spent this. And if you want to include the names, you can include the names in this. Okay, so now I'm becoming more flexible. We are now trying to make it more flexible. I said, everything is going bit by bit. From there, we now go and introduce even parameter in the method to make it more flexible. Because here, as it is here, we don't have the name of the person, and this original price is static here. We can make it dynamic in a way that when we say find total, then it passes the total here and then sends for calculation. So, but it's possible to do the same work in a single line. That's it. It's also dangerous to write programs that assess fields directly. That's the danger of the public there. To assess the field directly is highly dangerous, make it non-skilled. And we say Java provides security. How does it provide security? At different level, can you assess every field? No, there is restriction. That's why we are public, protected, and private. There is also default access modifier. So you will learn about this later, which not now. Later we talk about the public, public, private, and protected. The goal of this lesson is just to prepare you to work with important Java provided classes, not to impose any restriction. But later we talk about the public the access modifier, public, protected, and private. So we remember the Jobtion pane to receive users' input as usual. So you can just make use of this to say, okay, what is the expenses rather than hard coding. You see here we had coded the original price. Each time we want to calculate, then we come here and make it static. So if the user has access to this, we say we want to form a calculator. So how would you form a calculator if we have the source code where the number needs to go and modify it? So we can, instead of this now, we can just make use of the Jobtion pane and make it like this. Okay, Jobtion pane J pane dot show message, show message dialog. So you can just say, enter the price. So if you say enter the price, when it comes to, then remember you have to import always. It's just missing input. Okay, so yeah, it's imported here.
Input dialog, sir.
Sorry?
It will show input dialog.
Show, okay, yes, thank you. Show input. Show input dialog, thank you. Oh, it's still okay, only that I don't want to change it to string, but you see the danger of this, like I always said, you have to convert it to what? Double. So you have to use a wrapper class, double dot pass double. Then you now double. Let me cut it. So you have to use a wrapper class, say double dot pass double. Then you put this. Then that's all. Because whatever comes from here, it comes as a string. So don't forget that. So you see, so it now asks you, enter the price. So rather than hard coding, but the next one, since it doesn't have the option pen, it will go direct. Yes, it will go direct. But you see, this one has, and if you want to repeat, you can repeat. For this, just copy and paste and do the same for this guy. That's all. So you can do the same for even for tax. You can say, okay, enter this, and what is the tax? Like that. That's all. Okay, so yeah, is it? You will find that many methods are affected by arguments. Yes, like this calculate. So this is where we have the argument. When can method accept argument? You find that many methods are affected by argument, but method must be written in a way to accept argument. Otherwise, the compiler complains. So if there is an argument and you don't pass the argument, so compiler complains. Yes, just like in some situation like here now, we say calculate. So what is the price? What is the tax? So we need to pass it as an argument. That is the idea now. So otherwise, the compiler complains. So the calculate method is written to accept no argument. The one we have implemented, written to accept no argument. So if there is no argument, like the case where we say calc.calculate, okay, fine. No arguments, then good. But with arguments, and then we define it this way without any arguments, and we come and pass it. Sorry, we define it with no argument, and we come and call with an argument, this fails. And for that, there's no way. And the reason is, look at it here. The void is defined without any argument. And when you come to call, you call with an argument. Argument meaning that, look at here, in this bracket, within this calculate, there is nothing like an argument here. So when you come to call, you cannot pass an argument. Like here now, we have two arguments that are passed, argument values that are passed to the calculate, while the calculate method does not have any arguments. So that's cause an error. So how do we define the method argument? In the situation where we want to define the argument, we just come here and say calculate, then we now pass the two arguments, x and y, for instance, where x is integer, where y is double. So we come here, we pass the integer and double. So in this case, this is good. You can pass. You can pass that. Just like we go back to our program here, and then go to the find total. Let's say here we said price. We pass it here to the method. So we take this guy away. We take this guy away, but we come here and make it to be integer here. So this is fine now. So we have taken it away from here and find it, put it here now. So when we go back to this where we said this, no need. So if you like, you can just make it to be just an integer here, a sign. Then when you come to call, you can just pass it. So let me say price, so that you don't look at it as that must be the same. Okay. Okay, since here I said double, so I have to come here and make this also double. Yes. So when I come here, I said price this. So when I come, I put this one here. Double price. Original price cannot be resolved. It's not a field. Okay. Cannot resolved or is not a field. Original is just a memory, something is going to disappear. It's okay. Only that if at all I need to remove is this. Let's say this is price 2. Let's say double price 2. Let me make this one to be price 1. Okay. Then I will come here and make this to be price 2. Okay, so here now, I'm saying price 1 rather than calling this price to change, which already has been changed to as to this to be as parameter. So when I come here, I ask for the price 1. When I assign the price 1, then I will pass it here as price 1 and then calculate, find the total. Again, I received another price from this, which is called price 2, and then find the total. So we do that, then that's fine. This will now prompt us to type, enter the price. This is the price, the next price, this is the price, and then we see the results. So you see, we change this to parameter. Just look at this, find total with one parameter, because the way it is defined here, find total is a certain parameter where it tells the original price. So it will come here and put it here, calculate, and then return or display the total. That's all, nothing more. So if you like, you can just say total rather than total 1. You can just say total because there is only one total, but writing total 1 is still no bad. Yes, guys, any confusion from that? Any confusion? Did you get it? If you don't get it, please stop me and ask question.
Well understood, sir.
Okay. Now, next is argument order matters. Argument order matters. What we mean here is, let me come here and add another argument. Let me say it here. I want to add the tax to this. I want to pass the tax to be an argument. But let me make this one to be an integer, for instance. Let me make this one to be the tax to be double. Okay. So I said the tax now is going to go because I changed it to be as a parameter here. Then this one is integer, this one is tax, and tax is here. Okay, so I go to this class. If I want to call, I call with the percentage. So I can now say the percentage of this tax is 0.15. Now the tax for this is 0.661, high tax. Now, so, but don't forget that the type, we change the type to integer. So I have to use integer here. Dot pass int using a Rafa class to change to integer. I believe you can all remember this. So I will now change this to integer. I will change this to the integer like this. Okay. Now, so what we are saying here is the order is highly important. The order is important. So it's saying this type is not appropriate for the arguments int and double. Yes. So this is the ordering I'm talking about now. One thing check here. Anyway, it's because I didn't save this, but let's see. You see, I've saved this. This accept how many parameter? How many parameter defined for this find total? Who can tell me? How many parameter or argument defined for find total?
2.
Two. What are their types?
Int and double.
Int and double. Great. So when we come here, all we need to make sure that what we are passing is int and double. Int and double. In that order. So come here. Price. Is price int?
Yes, sir.
Yes.
Okay, fine. Is this double?
Yes, sir.
Yes, sir.
Okay, so now, which is compatible, right? So now, let me just change this. Now, what is the type of this?
Double.
Double. What is the type of this?
Integer.
Int.
Does it match with this?
No, sir.
No. So therefore, definitely error will be thrown. There's no way compiler will not accept this because there's no match. In fact, since we're using an IDE, you can even see it here. It says what? The method find total is of type int and double, isn't it? In the type calculator, it's not appropriate for the argument double int. It's not appropriate for the argument double int. So it's giving you an idea. So you right from here, before you even go and compile and run, you'll see that. But if you attempt to go, then definitely compiler will report the same error. Saying the methods, this, and this. So it's the same thing as when you hover this, you will see. So the best is to put them in their right order. Okay, so now suppose I now do this. Is it possible? Int. While there I have int double. Is it possible?
Yes.
Why?
Yes, sir.
Why?
Because
It will convert.
Interesting.
It will
Sorry?
convert it
Yeah, it's able to.
double.
Yeah, it will
Because
convert this one to double. Remember,
double,
from
yeah.
lower to a higher. From lower to a higher. There is expecting what?
Implicit
Double.
conversion.
And here we are passing a lower value, which is 1. So it's going to automatically convert it to what? Double coercion. Thank you. So it's going to take it as 1.0. That's all. 80, 100. Here is it. There we go. So don't forget, all matters is when you have an argument, the type of argument must match, the number of argument must match. But if the order, let's say you have an integer, and you come and swap this, even though it's an integer, but you swap them, not a computer cannot differentiate, cannot read your mind. Where you are supposed to say, let's say both of them are integer, let's say age and number of people. Let's say age, number of people, number of students, for instance, and the age of particular student, or the age of their lecturer. The age of their lecturer and the number of students. So where you define the method is age of students followed by the number of, so the age of a number of students followed by the age of the lecturer. But when you are calling the method, you now pass the age of the lecturer first, followed by the number of students. Yes, the computer will accept because there is match already in the type. Yes, so that swapping is done by human error, and computer cannot detect to know, oh, this is supposed to be for the number of students, supposed to be for number of, except if there is a validation to throw some invalid input to say, okay, no, we know that the age cannot exceed this certain limit. So by the time it exceeds that limit, it knows something is wrong. Then you reject it, which might not always be the case. So such are the things that one needs to be very careful when defining and making a call, so that you don't go and make a wrong call with different data. Okay, so I think this is it for this. This is another exercise for you guys. Take time, do them. Okay, so method, argument, and parameters. Argument is a value that is passed during a method call. So during a method call, at least we have called already. We define, and then we now pass the argument during a method call. Yes, during a method call. So this is where we pass the argument. Yes, and then we call them parameters. The one you have, we call them parameters. The where you call them what? Arguments. Yes. So this must match with this. You see, this is integer, this is double, then there must be a match in that order correspondingly. Yeah. So again here, we may have a method parameter. Method may have many number or type of parameters. So this is what we call method overloading. There may be many methods and number of parameters as well. Like this one, this is a method one with no parameter, method 0 with no parameter, method 1 with 1 parameter. But if you look at everything, it seems to be doing the same thing, only that this one is performing a division, this one division with addition here, something like that, most likely. That's just the difference. Yeah. So this is a method, this is another method. So you can have as many number of methods and with different number of parameters. Yes, so this one has no parameter, this one has 1 parameter, this has 2 parameters, and this has 3 parameters. So it all depends on the situation. You may need to have 0 parameter, 2, 3, 4, or any number. So the scope of parameters, to what extent can you assess a parameter? It's just within the block in which it is defined. Like here now, you cannot go outside. You cannot go outside this method. This is argument, tax. This is argument. So this is parameter, original price. This is a parameter tax. So outside this bracket, that is from here to here, you cannot assess them. Their scope is just within the fine total. When I attempt to call tax in print tip, I'm going to have an error because it's going to complain, cannot find symbol tax. Let me just come here and say, for instance, I want to add with this now to print it out. So you see, it says what? Tax cannot be resolved to a variable because it doesn't see it as a variable. simply because tax here is an argument. It's a parameter, and therefore, if it is a parameter, the scope of it means to the extent in which it's going to be visible, it's just within this opening and closing bracket. Outside, not possible. So that is why we are saying that the scope of that is just within the block in which it is defined. So within the block in which it is defined are variables that exist within the entire scope of a method. They are created within the method declaration. Scope refers to the block of code belonging to a method following its declaration, like this one, X and Y. The scope is just within this. Outside this, you cannot access X and Y. So how do you make a reference to parameter of the method? I think it's also, we have seen that as well. It's just a call. So here we have a method called calculate with X and Y as parameters. Yeah. So here we come and create another this and then have this. So what we are saying here, the X and Y does not mean are visible in this second method, calculate to. They are not visible. X is not visible. What is saying is what is X? Because the scope of X is not to, does not extend off to this calculate to. It's just within this calculate. It doesn't go down beyond this bracket. So this is why we say the scope of X is just within here. The scope of X and Y, and you cannot access them outside. So this is not possible to access them. So your friends are blah, blah. This is another question for you guys. So, okay, so now, which I'm sure if you want to add the name, you can add the name of the person, the price, name, and the rest. So like here now, we can go and modify this program and simply set if we bring the tax back to its original form, I take it there, but here I want to include the name. So I say string, the name of the person, so that when we know the total, we can say the total is this. So we can say total for, anyway, let's say name column plus total, just to print the name and the total so that we know whose total is this. So we have the argument. So we go here, instead of, you see, now it's complaining. It's saying what? Remember the type here, we have in this parameter, we have what? Original, the price and the name. So and the name is a string. And what we have here, of course, we have this as integer price, but the name, this is one, which is not a string. So I will just make it to be a string, which is typically the name. Then on the second one, also, since I've changed the tax, then I make it like this. So I run, we see that it asks us to tell the price is this, the next price is that. Then we now see Aliyu, Alex, this. So at least we know the total for Aliyu, we know the total for Alex, and that's right. So that is having another something, so that we know the total is for who. We can't just get total without knowing. So that's why that's the method is refined now. Okay. So I think we have almost, I want to get to the end of this slide, then stop. So this is the test method, the calculate test, where we have the public static void main. And this is our main class. And with this, we have a method. And this, in the method, we have a total. So we don't get the total. How do we get a total? We use that formula. So here is it now. This, calculate, find this, calculate, find this total, given the the price as this, the price as this, and then we say calc dot find total plus calc dot find total 2. So there is something this is telling us. This is going to throw an error because having a print method, the find total here is void. When you have a void method doesn't return any value. So when you call find total and attempt to print it as if it's returning a value, then you're going to have an error. So what we are saying is this. Suppose here now where I said this, let me cut it and just come here and said system dot out dot print line, for instance. So I now put in this guy here. So this will lead to an error because the calculate find total, the find total doesn't return value. And if it doesn't return value, how can I have a printout of what is not returning any value? So this is why that error will occur. So you see, it's even saying the method, this in this type is not applicable to the argument void. Yes. Because this is a method that doesn't return value. It's only printing. Yeah. It's only printing. Because it's a void, it's only printing the value here. If it's not going to be void, then I have to specify what type of data is it going to return. Then we should have the return keyword. And that value that is returned, if I come here and I print it, then I will see the result. But any void method cannot be used to call inside the print line method. So this is the case now. I don't know, is this clear or not clear? This particular one. Hello?
Yes, sir.
Is clear?
Yes, sir.
Okay. So this is the arrow they are talking about now. So we have seen this show dialog. What is a void type? Method return type. So the method return type, a method sometimes may, if it's a void, it means it doesn't return value. So like show input dialog is a string type method, meaning it returns a string, like here now. Remember, show input dialog is a method and it's returning a string. Regardless of it, it's returning. That is why even if you type 1 here or 510, we have to use this wrapper class to convert it. That's why we have this integer.parseInt to convert whatever we receive from the Jobson pen, show input dialog, to the appropriate type, which is in this case integer. And if it is double, use a double. So that is it. It's because it returns a string. So this is it now. So after you type in here, whatever is returning will be assigned to this input, and this input is of type string, which is okay. So some methods may want to return value. So that's why we have method return types. Variables can have values for many different types. So it could be like we may want short int of any of these, or it could be the object itself. So a method call returns values for many different types, like this. So how to make a method return a value? Declare the method to be a non-void return type. So non-void means should not have a void declaration. And then we specify the return type. Let's say, for instance, we come here and define a method. Let's say public, let's say int, and I say get tax. Get tax, get me the tax. Then I will come here and say return tax. So here I'm returning the tax now. And the tax is this. This is the tax now. Is the one I'm returning here. Type mismatch cannot be converted outside or int.
It's double, sir.
Okay, it's double. Yes, thank you. Okay, thank you. Tax is double, therefore we have a double here. So get tax is a method that gets us the value of tax, which is typically this now. So this is a method that has a return value, not a void. So when I go to the test, calculate test, I can call this get tax and print the result. So if I just say calc.get tax, I will not see anything on the screen until I have the print statement, because this is returning a value and the value is the value of the tax. So in this case, I can put this in public and system.out.println because there is a value returned by the method. So if I want to print out the tax, I can say system.out.println. Then I will set calc.getTask. GetTask, this is it now. Method is undefined for the result. Okay, I didn't save this. Okay. So here now, so when we run, we come here, let's say we append and say task. Yeah, now. So you see, we have the tax now. See the tax is just because here now we don't have the ln new line, so it puts the two uppercase of our new the same line as that. So here we go. You see the tax. See, this is a method because there is a return type here, and the return is double. Yes. So if you make this one to be an integer, while tax is double, then you're going to have an issue. The tax is double. So unless if you are going to cast this tax to what? To an integer. Otherwise, that will not be accepted. So be careful when using that. You make sure that the type must be the same. The type of the return type here must match with the type of value that you return to the method. So here now we have, this is for void, nothing for string, we say return hello. You see in code because it's a string and the type here is string. Here we see integer, therefore this must return an integer value, which basically x and y are integer and the result will be integer. So this is fine. Yes. But in case of, let's say here we come and say sum public int sum. So you remember that when you say x plus y, the answer will always going to give you what? Integer. If x is integer, y is integer. So if one of these is double, then the result x plus y will be double, while the return type here is integer. So this will not be accepted. You have to make sure that the return type of the sum of x and y must be compatible with the return type of the method, or else you're going to have an issue. So it's either to make this one, if you know the result will be double, then you make this one to be double. That's all. So you have solved the problem now. So if you are to go and call this, suppose this the calculation of the x and y need to be performed, you just come here because it's a calculator. So you can just come here and it has a return type. So you can just say system dot out dot print or print line, then calc calc.sum, then sum, you now pass the two numbers to sum. So let's say the sum I want is just to say sum of X and Y. Sorry, price 1 and price 2. That's all. So I here to say this one, then I see the sum, which is 45, 145. And this, remember, I'm calling this sum. This sum is from here. That's sum of the total price of all the guests. So we see Umar, Aliyu with this, Alex with this, and the tax is this, and the total is this. So if you like, you can add also the tax. So the tax is already been added, but just to display that, okay, this tax, everything was calculated. Okay, so I think we are there. So this is for the main methods. Says this one and this one, the sum. So the sum is called within here. You see, it says sum of num1 and num2 from here, X and Y. You make a call here, but remember this is static. So if it is static, you need not to create an object, because that is one good thing. A static method is a method that belongs to the entire class. Just like I said, that is something that is for all of us. Let's say we are to eat, but we eat the same food. So there is not any dedicated food given to you, and there is not any food dedicated to me. All we know, once we are asked to eat, go and eat the same thing. Yes. So that needs to make it like what, static. But your own name is different from my own name. There is no way your own name will be my own name, even if we have the same name. You have your name, I have my name. You have your GP, I have my GP. So there is no way we can share the same GP. But in the case where we are to share something, then we make it static, because it's not for a specific object, but it's for the entire class. So when we say static, it means something that belongs to the class, not belong to a specific object. Okay, so this is just illustration of passing a method call and exercises. So guys, thank you very much. I think we have reached to the end of this. So we are taking it gently, slowly, so that what we want, even if we cannot cover, but let it be like, okay, 100% or 99% chances of you understood the course, rather than to rush over and at last without any understanding, then the whole aim is defeated. Okay, so yes, question? Any question? If you don't ask question, I will ask. Okay, so in the absence of no question, yes.
No, there's saying no questions. I will be like, help us like send the video to the group, let's go, just to watch it and
Yeah, it's okay. I will send.
I was confused.
Yes, I will send as usual.